Look up at the night sky. It looks calm, silent, frozen. But the truth is, our galaxy is moving, not drifting, not slowly, moving fast. And for decades, astronomers have asked a question that sounds like science fiction. What is pulling us? Because the Milky Way, along with thousands of nearby galaxies, appears to be streaming toward a hidden region of space. A region we once named before we truly understood. They called it the Great Attractor. Here's the first twist. The universe is expanding. That means, on average, distant galaxies move away from us. The farther they are, the faster they recede. That is the basic rule of the cosmos. But the universe is not perfectly smooth. It is lumpy. And lumps have gravity. So galaxies don't just follow expansion. They also have extra motion layered on top. A gravitational pull that slightly bends their path. Astronomers call that extra motion peculiar velocity. It's the difference between where a galaxy should be going if the universe were perfectly uniform, and where it actually goes because something massive is nearby. And once scientists started measuring these motions across large regions of space, they noticed something disturbing. Many galaxies were drifting in the same general direction, like iron filings slowly sliding toward a magnet. So they mapped the motion, not with photographs, with numbers, redshifts, distances, velocities, and the pattern pointed to a place in the sky in the general direction of the constellations, Centaurus, Norma, and Triangulum Australe, a direction that should have been filled with answers. But instead, it was blocked, because between us and that region is a giant wall of interference, the bright band of our own galaxy. The Milky Way's disk is filled with dust and crowded with stars. It creates a blind spot in our view of the universe. Astronomers have a name for it: the Zone of Avoidance, a region where visible light surveys struggle because our own galaxy is in the way. So imagine the frustration. You detect a huge gravitational pull, you plot it, you triangulate it, and it points straight into the one part of the sky you can't see clearly. That's why the Great Attractor became a cosmic myth. People imagined it as a single monstrous object, a super black hole, a hidden galaxy kingdom, a dark, impossible thing dragging the universe toward it. But the real story is more subtle, and in some ways more impressive, because the Great Attractor is probably not one object at all. It's a region, a gravitational basin, a landscape of mass spread across clusters and galaxies, stacked along the same line of sight. So the mystery is not what single thing is pulling us. The mystery is what is hidden behind the Milky Way, and how much mass is really there. To answer that, astronomers changed the way they searched. If visible light can't see through the dust, then you look with other eyes. Infrared surveys can see deeper. Radio telescopes can detect galaxies by their hydrogen emission. And X-ray observatories can reveal hot gas inside massive galaxy clusters. And slowly, the fog lifted. Not completely, but enough. One name kept appearing near the heart of this gravitational region: the Norma Cluster, also known as Able 3627, a rich cluster of galaxies, massive, bright in X-rays, and located right where you would expect a major gravitational influence to hide. In other words, the Great Attractor region may be anchored by real heavyweight structures we can now partially detect, even if the Milky Way still blocks the cleanest view. But here's the second twist. Even in science, gravity can be misread. In the early days, some estimates of the Great Attractor's mass were extremely large. So large that it sounded like a cosmic vacuum cleaner pulling everything in. Later, Astronomers realized that some of the signal could be exaggerated by measurement bias and incomplete data. When you try to measure distances and velocities through a blind spot, small errors can inflate into big conclusions. So, the Great Attractor has been debated, refined, recalculated. But the key point stayed intact. Something in that direction is contributing to a large-scale flow of galaxies, and the best explanation is not a monster. It's structure, normal cosmic structure, just on a huge scale. Clusters, filaments, walls of galaxies, mass distributed across a region, not concentrated into a single point. So, what does it mean for us? Are we doomed to fall into it? No. This is not a cosmic crash course. On human timescales, the motion is invisible. On galactic timescales, it's slow. And on cosmic timescales, it's part of the normal gravity choreography of the universe. The Milky Way is one member of a vast web, and that web has currents. Galaxies don't just expand away from each other. They also slide downhill in the gravity field created by the cosmic landscape. The Great Attractor is one of those downhill directions, a gravitational low point in our region of the universe, hidden behind our own galaxy, but not beyond measurement. So here's the satisfying conclusion. The Great Attractor is not a single dark object. It's not a mysterious thing waiting to swallow us. It is the name we gave to a discovery before we fully saw it. A massive gravitational region, largely obscured by the Milky Way's dust, revealed not by a photograph, but by motion, by the subtle drift of galaxies